Good morning and welcome to AP Statistics. Today I'm going to first go over the homework answers as briefly as possible because I don't want this to be a 30-minute video, but in numbers 13 through 18, number 13 the estimates would vary, but should be close to the reported percents, 63% Mexican, 9% Puerto Rican. 14 estimates, again, can vary, but be about 20% business, 12% social science. And 15, pie chart could not be used for the data because the given percents represent fractions of different groups rather than one whole group. Part B was a bar graph, which should look something like this bar graph over here. So let's see if you can make it look like that. You can pause and check it out. 16 should look like the bar graph over here. Again, you can pause and check it out. Let's see, part B of 16, a pie chart cannot be used for the data because the given percents represent fractions of different groups rather than one whole. Again, part C, to know the percent of the audience is 18 to 24, we have to know how many people are in each group. Data did not tell us that. And 17, the area of the pictures should be proportional to the numbers of students they represent. As drawn, it appears that most of the students arrived by car, but in reality, most came by bus. 14 bus, 9 car. Part B, a bar graph as given below. So this little bar graph over here. And 18, did I give you too much homework? The vertical scale does not begin at 0, which overemphasizes the difference in the cholesterol. Part B, bar graph, as shown in a second, the drop in cholesterol is much smaller than it appeared in the original graph. Here's what it would look like if it's corrected. Obviously, a very, very small difference is being seen here. All right, 21 through 23. 21, for buyers, about 55.6% said higher, 19.4% said the same, 25% said lower. For non-buyers, 29.9% said higher, 25.8% said the same, 44.3% said lower. See that buyers are more likely to consider recycled filters higher in quality than non-buyers, and much less likely to consider them lower in quality than non-buyers. 22, the students with no parents who smoke was 86.1% don't smoke, and 13.9% smoke. For students with one parent who smoke, 81.4% don't, 18.6% do. For parents with both parents who smoke, 77.5% don't, 22.5% do. The conditional distributions reveal what many people would expect, that there is a relationship between smoking behaviors of parents and their children. And 23, Americans are much more likely to choose white, pearl, and red than Europeans, while Europeans are much more likely to choose silver, black, or gray than Americans. Preference for blue, beige, brown, green, yellow, gold are about the same between the groups. Finally, 27 through 30, multiple choice answers. 27, D like dog. 28, B like bear. 29, D like Dalmatian. Number 30, D like dinosaur. Number 30, yeah, that's it, number 30, we're done. If there's questions or problems with the homework, of course, ask when you see me, or if you want to send an email out for clarification, we certainly can do that too, but let's move on now. All right, so what I want to talk about today are a couple of different common graphs that we're going to be using. They are the dot plot, the stem plot, and the histogram. We're going to focus on the histogram for this lesson more than the other two, but here's just a quick example of what dot plots and stem plots are. A dot plot is real easy to make. You just have a horizontal line which indicates the scale we're talking about. So let's just say I had values that are counted off by tens, and I don't know, underneath the temperature on any given day in Connecticut in April. I couldn't tell you, I'm making this up as I go. But let's say we had the temperatures of 42, 45, 50, 62, and 67. Just to put some numbers on there. Oh, let me also throw in another 45 just to show what happens. So 42, well, this is where 42 would be. We want to mark it and put a dot above it. 45 is right there in the center. Again, I'm going to squeeze them in to write it down. Dot there. 50 is already marked. I don't have to write anything there. 62 would be about over here, so I'll put a dot there. 67's on this side, so I'll put about a dot there. And then there's another 45, so I'm going to stack a dot over here. And that would be the distribution of the numbers I just came up with. If I had more days, let's say there was 3 more days of 50 degrees temperature, there'd be 3 more dots on top of the 50. And by looking at a dot plot, you can kind of see the distribution of the temperatures, in this case, among those days. Dot plots are real easy to make. You just make a number line and you put the dots above the values where they fall. And if there's more than one, of course, they stack evenly. That's a dot plot, pretty easy to use. A stem plot, sometimes called a stem and leaf plot, is also pretty easy to use. I'm going to give you some data. We'll talk about, let's say, test scores. So we have the following test scores. We got a 40, not so good, 68, 72, 78, 82, 90, another 90, 98, and a 58, a 70, an 84, an 88, a 90, an 85, and a 74. Okay, well, these are the data points we're going to use. A stem plot is pretty easy. We sometimes call it a stem and leaf plot. I'm going to make a vertical line over here, and on the left, I'm going to put the stems, we call those, in this case, the tens places. I'm going to use every tens place that falls from the lowest in the range to the highest. The lowest score was 40, that's a stem of 4. And the highest score was a 98, so I have to count everything between 4 and 9, so 4, 5, 6, 7, 8, and 9. It does not matter if there were no 60s, for instance. We'd still need the stem there because it falls within the range. The leaves are the single digits placed in each of those values. So we're just going to put them in as they appear. We can sort them or we could not. It doesn't matter. There's 2 different kinds of stem plots. There's ordered and unordered stem plots. We always prefer the ordered ones because it's a better picture. Ordered means that they will be, the leaves will be in order. So how many 40s were there? Well, there was just the one over here, so I'm going to put a 0 for 40 because that's the one's place value for the number 40. There was also a 58, so I'm going to put, there's no other 50, so an 8 goes here. For the 60s, there was just the 168, I think, right? Yep. The 70s, we had a 70, a 72, 74, 78. Let's just make sure we're not missing anything. 70, 72, 74, 78. So 70, 72, 74, 78. That's how we're going to draw them. The 80s, we have 82, 4, 5, and 8. So 82, 4, 5, and 8. And the 90s, we got 3 90s and a 98. So 3 90s are going to be a 0, a 0, another 0, and an 8. Each one counts. And that's my stem plot. It shows the distribution of scores. If you take a look at it, you see that we have very few low values. And then we have 4 values in the 70s, 4 values in the 80s, 4 values in the 90s. And we could also count in to find, let's say, the median score. We can also look and see really quickly that 3 90s occurred in this data set, making the most common value, the mode, a 90. Okay. Stem plots are helpful. We'll use them from time to time, but the majority of right now is going to be spent on histograms. So here's what I'd like to do. I'm going to basically use the same data set to make a histogram, and I'm just going to rewrite those numbers over here. So what did we have? Well, if you wanted to write yours down, that's good. It was a 40, 68. That's the reason I want to write it down again. 72, 78, 82, then there was the first 90, the second 90, then a 98, a 58, a 70, an 84, 88, 90, 85, 74. Okay. So there's 15 points of data up there on the board. A histogram is basically a bar graph whose bars will touch, and it's based on what we call, again, quantitative data. So we have a number line horizontal axis. Bar graphs are usually used for qualitative data. So, the color of car, and therefore the axis would have, the colors, black, red, green, yellow, and they wouldn't touch because there's no reason for those bars to touch, as those categories are not continuous. Okay, so here's what we're gonna do. A histogram is going to end up looking something like this. So I'm just going to show you real quick. Here's what a histogram might look like, okay? Where you have a 0 at the origin, you might have a break in the scale, and you're going to have numbers. You have to figure out what those numbers are going to be to identify what we're going to call the class boundaries. That's the points that form the beginning and the end of each of those columns, also called classes. On the vertical axis, we're going to have what we call relative frequency, and you'll see what that is in a second. But it shows you, related to the rest of the distribution, how the frequency for that class fared. Was it a high frequency column or a low frequency column? And that tells you how common values fell inside those fields. Okay, so understanding what it should look like, we're going to try to make one, okay? So here's what we're going to do. First thing you have to identify is the range. Okay, that's easy to do. The range is equal to the high minus low. And in this problem, the high value, I believe, was a 98, and the low value was a 40. So 98 minus 40 is a range of 58. So far we have the range. In order to figure out how wide each of our columns will be, we call that class width, we have to decide how many columns we even want. Histograms should have between 5 and, let's just say, 10 columns. It depends on how much data you have. The more data you have, the more columns you can use. It's safer to spread that data out. The less data we have, the fewer columns we want to use, because if we spread the data out too much and there's not much data to begin with, we get a very flat looking graph. Because there's only 15 points of data, I'm just going to choose 5 columns in my histogram. We're making a choice. So my class width is what we call, again, how wide the column will be, is equal to the range divided by the number of classes or columns. We're going to call them classes because that's what they're called. And again, the number of classes could be something you decide, or it's given to you in the prompt. So in this case, 58 was my range. My class width is 5. 58 divided by 5 is 11.6. Here's something about the class width. You always want to round it up. Even if it were a whole number, even if it were 12, you'd want to round it up logically a little bit. You can call it 12 and a half in that case. 11.6, I'm going to round it up to 12. The reason why you always want to round up is because if you do not, you might find that you run out of room for your highest data point. We don't want to run out of room. So I'm going to call my class width 12. All right, now that I know my class width, I'm ready to create a little table called a frequency distribution that will allow me to build a histogram. So the frequency distribution, I'm going to abbreviate it a little bit, is a very short table that helps you make that histogram. 3 columns is all you really need. You can use 4 if you'd like. I'll show you why. But the first column is going to be called class. So we're going to create a column that we're going to call class, and give it some space. The next column, if you don't, well, if your data is in order, you could skip the next column, but our data is not in order. So in order to not make mistakes, I'm going to use what's called a tally column, where you use tick marks to count off values that fit in the class. And then there will be a frequency column. And the last column is called relative frequency. It's actually a very important column to make. And it's going to be what I'd like you to use for the histogram. So I do need a relative frequency histogram. Here's what I'm looking for. The classes are going to begin with the smallest number in the data. In this case, 40. Now the classes are going to go up to a certain number, which we're going to use the class width to help us determine. But here's how you're going to do it. The class width I have is 12. Obviously, 40 plus 12 is 52. But that's not going to go over here. That's going to begin the next class. So the class width is the difference between successive lower boundaries. Add 12 again, you get 64. Add 12 again, 76. Add 12 again, you get 88. I'm not going to add 12 again because I have now the makings of 5 classes. I decided I wanted to use 5 classes, so there will be no additional class. Now, how do you find the upper boundaries? It's not that hard. If this class began at 52, the previous class had to end at 51 because we can't overlap our bounds. If one class goes to 52 and the other starts at 52, where does the value of 52 go? It's got to go in one or the other, so we can't overlap the boundaries on a histogram. So the first class goes from 40 to 51. The next class goes from 52 to 63, since the next one begins at 64, to 75, since the next one starts at 76, to 87, since the next one starts at 88, up to what? Well, remember, our class width is 12. And since it's 12 between lower boundaries, it's also going to be 12 between upper boundaries. So add 12 to 87, and you get 99. That is what we have to do. We're not going to just call it 100. We're not going to do that because that class would be wider than the other classes for no good reason. We don't like that. We don't want to do that. So the tally is where you put the tick mark. So 40 goes in the first field. 68 goes down here. 72 also goes down here. 78 and 82 go here. That's my first row. 90, 90, 98 goes here, here, and there again. 58 and 70. 58's down here, 70's over there. 84, 88. That would be 84 here, 88 there. 90, 85. That's 90, 85, and 74, which goes here. So how many points of data should I have? Well, I already said I should have 15 because that's what I put on the board. I put 15 points of data. At this point, you should check because if you skipped a data point, it's a problem. Let's count up. We got 1, 2. Okay, well, might as well just write them here. This is the frequency of one tick mark, 1 tick mark, 4, 4, and 5. That's what those are. Now, what's the sum of 1, 1, 4, 4, and 5? Hopefully you figured out it's 15. There's notation I want you to use. This is a capital sigma. It's a Greek letter. It looks like a jagged pointy E or an epsilon. You've seen it, I'm sure, in Greek lettering. It's a sigma, capital sigma, and it means the sum of. This column is called frequency, so I'm going to put a little subscript of F there because it's telling me it's the sum of the frequency column, and the sum is 15. Which checks out with the data that I collected. I want to make sure that I've actually accounted for all of my data. Relative frequency is an important field. It's where you divide the frequency for the column by the total count in the distribution. So relative to the distribution, what percent of our data falls into this column? 1 divided by 15 is 0.0667. Go to 4 decimal places. The 6's actually continue forever, but I want you to round to the 4th decimal place. In this class, always the 4th decimal place. Don't cut it off earlier than that. This is also 0.0667. 4 divided by 15 is 0.2667. And since there's two of them, it's easy. And 5 divided by 15 is 0.3 repeating, so I'm going to go to 4 decimal places. It's also important that we add this up to make sure that we haven't made mistakes. Obviously, we don't want to have anything other than 1 or very, very close to 1. Now, when you add these up, because we had around 4 of them up, we actually get a number that's a little bit higher than 1. It's a very little bit higher than 1. It's off by 1/10,000th, which is okay. We call it round off error, okay? Round off error. And it's acceptable to have round off error that is generally 1/10,000th, 1 of your smallest place value. That's acceptable round off error, okay? Now we have everything we need to make the histogram. So I'm going to just shrink this down for the purpose of leaving it on the board, but also having room to work. I'm sure you either have it or have made your own. So here's what I'm going to do for a histogram. I'm going to make a first quadrant graph. I'm going to put a 0 in the corner and a break in the scale because we're not going to be counting by the exact same increment starting from the origin. So we want to have that break in the scale. I need 5 classes, which actually means I need 6 tick marks. 1 has to begin the graph. So tick mark 1, 2, 3, 4, 5, 6, about equally spaced, okay? Now here's another little issue. It's called a continuity correction. We want these bars to touch, correct? But 51 and 52 don't touch. So if the first bar goes from 40 to 51, and the next one starts at 52, and this is the number line, there's a discontinuity, there's a gap there. We want to bridge the gap. So they're going to meet halfway at the half mark. So this is my first column. It's going to be whatever tall it's going to be. And it's going to go from something up to 51 and a half. So this mark is 51 and a half. This is going to be 63 and a half. 75 and a half. 87 and a half. We have to be continuous. We can't just stop at 99 and a half. Now, because all of these went up, there's a reason why I didn't start this at 40. Again, to be continuous, they have to have the same gap, the same distance. Right now, for instance, this one has a gap of 12, fortunately. So this must also, so it doesn't really start at 40. It starts 39 and a half. It starts 1 down. The continuity correction is a half a point down on that first class, not up. The first class is the only one where the beginning is actually a continuity correction down from the first data point. Rather than starting at 40, it starts at 39.5. Every high value, every upper boundary of our distribution has the continuity correction added to it, not subtracted from it. Okay, we're almost there. Relative frequency is what I want. I'm going to abbreviate it RF. This is class. Relative frequency is the vertical axis. How high does it have to go? Well, it has to go only up to my largest relative frequency, which in this case was 0.3 repeating. I'm just going to give the, let's say 0.05. So 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. I kind of ran out of room, but again, fairly equally spaced. Fairly, not perfect, but it is what it is. I don't need a continuity, I don't need a break over here. The reason I don't need a break over here is because I went up by 5% every time. 5%, 10%, 15%, 20%, 25, 30, 35. If I didn't, I actually would need a break on that axis also. Continuing, so the first one has a height of 0.0667. I'm gonna put it about over here and make my first column. Do you think I did it perfectly to 0.0667? I highly doubt it. So anyone who's looking at the graph, to tell them where that is, I'm gonna write the number right on top of it, 0.0667. 6, 7. The second one also the same height, so I'm going to put it there too. I could write it again, 0.0667, because there was no difference between the first two. The second two both go to 0.2667, so I'm going to put them where they belong, 0.2667, and give or take around over here. I'm going to actually make it all the way across and then split it because they are the same height. 0.2667, 0.2667. My last one, I'm kind of running out of room to actually draw anything, but I do want you to see what it should look like, so I'm going to apparently overwrite it because I can't quite squeeze it in there and I can't move that part all by itself, but this goes to a third, so up to, let's say over here. Whoop, that's not what I want to do. Okay, well, it's moving around on its own, but I want to draw, not move. So up to about over here, and I'm just gonna not really, I don't want to write over everything, but that's where it would go. And I'd say 0.3 repeating. You can obviously tell that I didn't leave myself enough room, but hey, that's what happens. I also want to give a title. I'm just going to call this grades. Give it a title. Now we have our axis labels of relative frequency and class. We have a title of grades. We have our class boundaries. We have our continuity corrections. We have our break. We have our scaling. We have our numbers on top of our bars. That's a histogram. Specifically a relative frequency histogram. What I'd like you to do is on page 43, look at the data set for problem number 47. I also will have attached to the Google Classroom a picture of the data set. I want just a relative frequency histogram of that data. Again, it does require everything you see over here. So I want to see how you found your class width. By the way, use 5 classes for this histogram. I'm telling you, because it doesn't tell you in the problem, 5 classes for the histogram. Round appropriately for the class width. Make your frequency distribution, being careful about the classes. Tally, frequency and relative frequency, be careful, make sure that you don't have too much round off error, and make the histogram appropriately, and that is all I've got for you. So do the homework assignment, please, and submit it electronically for Monday. Everyone's distance learning Monday, so make sure that you have sent it to me on or by Monday, and I'll go over it then. Have a wonderful weekend. I'll talk to you guys soon.